All right, so I'm gonna walk you through some of the problems that are on lesson 2-1 that you can find in your textbook on page 17. I'll show you. Here it is. Just like I said, we're on this. Notice it says page 17, and then here's the problem. Now, for time purposes, you should, on your own, you should go back and read all of this, okay? I didn't cover this right here. I'll show you what I did. I did take this information and I came up with this word problem. I didn't change anything. So if you go back and read problem number one, you should come up with this number. I'm just trying to streamline it and get it down to more resemble the question that you're going to have to do in your homework practice. So Springboard went into a little bit more depth, made you do some thinking, and I just narrowed it all down to for you. So the story is that Roy, I have such a hard time saying that name because I want my R to sound like a W. So you're going to hear me really struggle. Roy won some money and wants to go to New York City. He's already bought his plane ticket with his winnings. He already paid for his hotel with his winnings. And then after he paid for those two things, the money that he has left over, he has this is $1,360. That's how much money he has left to spend. And he only wants to spend this. He doesn't want to spend any of his own money. He plans to go to the theater or maybe to some musical performances, and on average, a ticket for performances in New York City costs $100. So they want us to write an equation. Now, you don't have to necessarily write the equation by doing the table first. I guess Springboard thinks that that is the best way to start this problem. But you should also be able to read this problem and go straight to number 5. Write a function that represents the amount of money that Roy has left after purchasing T tickets. I am going to go in the order that we did it, or actually I'm going to start off, well, maybe I'll start off here. We'll write this. Now, they're using M of T, they're using function notation. And remember, this represents the amount of money that he has left, okay? So he's starting off with some money. How much money does it say he's starting off with? He's starting off with $1,360. Now that's an initial amount. This is what he's starting off with. After, of course, he's already spent those two. Just when we're talking about this is the money he has left to spend on the theater tickets. So it's not technically the amount of money that he started with. I think he started off with $3,000, but this is what he has left to spend on the theater tickets. And he says that he's going to spend them at $100 per ticket. So we're going to take away from that. Why are we taking away from that? Because his money is going to decrease. All right. And we could also point out here that, and we should point out up here that T is the independent variable. And it represents, and the reason that I'm writing this is because this is what you have to answer in your homework question. It represents the number of tickets that Roy buys. Okay, T is the independent variable. How do I know it's the independent variable? Because we have to know how many tickets he buys before we can know how much money he has left. Now, the dependent variable is not really a variable. They're writing it as a function in terms of T. So M of T is the dependent, and I'm abbreviating that, dependent variable, and it represents the money left after buying tickets. Okay. So those are the independent and dependent variables. He starts off with this much money. He's going to spend $100 at a time. And that's how much money he has. Now, if we would have filled out this table over here, he doesn't buy any tickets. He has $1,360. He buys one ticket, he has $1,260, and so forth. 1,160, 1,060, 960. I'm going down from 0, 1, 2, 3, 4, 5. So I'm keep going. That's 860. But now all of a sudden they want to know how much money it is if I have 8 tickets. And then I think, what pattern do you notice? And explain how you would determine. Well, since I kind of cheated and wrote the equation first, but I'm also going to show you in just a second how this equation right here can be figured out from this one right here. We know this, since it's 0 tickets, we know this is the y-intercept. And since it's the y-intercept, we know it's the value of our b, okay? And there's my b right there. For my y equals mx plus b, that's my b. I wrote it first, and the reason I wrote it first is because I'm decreasing that money, and I wanted to take it away. So then we're going to find the minus 100, because each one of these amounts is going down by 100, because every time I buy a ticket, I spend $100. It works fine until we get down here and notice that this is a change of 1, change of 1, change of 1, change of 1, okay? So it's going to work fine until we get down here. Now it's not a change of 1. It's a change of, from 5 to 8, it's a change of 3. So since this was 100 every time we changed 1, if we change 3, what do you think this one's going to change? Right here. It's going to change 300. And how do we know? Because it's got to reduce down to 100 over 1. Another way you could do it is, since we don't know if you want to wait before we get to this point right here, let's plot these points first. Let's go to 1,000. I think that's $360 is going to be somewhere right around there. And we're going to talk about this graph because we don't have a title for it. And this is, I'm going to call it Roy's balance. And if y'all don't, if you've never had a checkbook, you may not know what I mean, but a balance is how much money he has left. So this is Roy's balance, or you could put how much more Roy has left. That's too many words for me to write. They titled the x-axis tickets, and then they scaled. Each one of these is worth 1. So this is 1 ticket, 2 tickets, 3 tickets. The y-axis is labeled money available, or you could put money left. And this is scaled by 100. Some of you would say it's scaled by 200. No, it's not. That mark right there is 100. So 100, 200, 300, 400, 500, 600. So this is 1,200, 1,360 is going to be somewhere right around there. And then I'm going to go, when I buy 1 ticket, it's going to be up at 1,260. And then the next one's going to be, this is at 1, this is at 2 tickets, it's going to be up at 1,160. Okay, and so forth. So I've got enough right there. If I take my ruler over here, I got to spin it just a smidge. That's pretty close right there. I'm afraid if I spin it anymore, it might be too much. That's pretty good right there. So I'm going to use that ruler right there to make this straight. Okay. And now I can see that at 5, 6, 7, 8, I can see I'm right at 760. So if I no, sorry, 760 is up here. I'm right at 560. And if I take 300 away from 800, you'll see I'm at 560. So my plan right here, since this changed by 3, that changed by 3, I'd be down by 560. And if I go over here to 8, there's 200, 400, so that's 500. And we know each time these were 560s. I'm off just a smidge, but for goodness sakes, that's close enough. Especially since I was kind of, freehanding it. So, explain how you would determine the values for 8. You could do like we did for a change in x's of 3. I will have a change in y's, and that triangle, this triangle is the symbol for change. You know that from science. The change of 3, change of in x's, the change in x's of 3, I should say with a change in x's of 3, I will have a change in y's of 300 based on the pattern. Based on the pattern. Okay, so give me another reason. Another that would be one thing you could do. Another one you could do is say using the line I graphed 8, 560. Or I could see 8, 560 was on the graph. Using the line. So that was one thing. And then like I said, we cheated and we wrote the equation first, but you've got enough information right here to say, okay, here's my y-intercept. My slope is changing 100. So if you write the equation, you could write the equation and plug 8 in for t. And then if you say 1360 minus 800, because 100 times 8 is 800, you get 560. Okay, so m of 8 is equal to 1360 minus 800, which is 560. So there's 3 different ways right there you could have done it. My video is probably running a little long, so I'm going to go ahead and stop before we go on and talk about anything else. Got to figure out how to stop it.